Hello, YouTube. RJ. Hey, last time we were working on the 428B that I restored in the previous series, I mentioned that I have the old one that we stole parts from. We weren't going to be able to use as a repair. And I said, that'd be a neat item to use to convert to a high voltage power supply. I don't have one and I need one. So I gave it some thought. And so today we're going to start the conversion process. I'm going to convert this, make it look nice, and turn it into a high voltage variable bench supply. As I was looking through it, it became very clear that you already have a high voltage regulation system in here. It's not adequate for our needs, and I'll explain in a minute, but I think we can tweak this and use it. Keep this thing a tube-based high voltage regulator. So here's what we've got. There's 3 tubes in this unit that regulates the high voltage. You've got V9, V10, and V11 over here. And you have a pot right here, and this pot is to adjust to get your plus 272 high voltage, and it tells you to measure that on pin 1 of V9. Okay. Now they gave you some, that's what the pot's for. They gave you some variable of the voltage to tweak it into 272 volts. Now they didn't want to give you the ability to swing it wide because you might bring the voltage out of range of some other sections in the unit and damage them or cause problems. So what they did is they put guardrails up. They designed the circuit to be close to 272 plus or minus, say, 10 volts. You can swing this thing around about 20 volts or so one way or the other. Well, obviously that's not going to do for us. Number one, we'd like this thing to be higher voltage. I'd like to be at ideally at least 300 volts, maybe more at the top end. And I want to be able to bring the voltage all the way down. I want to get it down at least, say, 60 volts to the minimum. 0 would be better, but that might not be possible. So that's kind of where I'm going. So what we've got is we've got circuitry with these 3 tubes that is designed to limit our varying. And so my idea is I'm going to redo the circuitry to take that guardrail off. Don't worry, I'm going to have it disconnected from the other circuit, so doesn't matter. They'll never see it. Let me move this out of the way here. Bring some paperwork over here, and let's talk about what we're up to. Okay, so I got you where you can see this a little better. Bar is going to be in my face, but we're going to be looking on this paper anyway. So let's talk about it. Now, when we look at this, what I've done is I've cut out the regulated high voltage supply section of the schematic. Even then, it's pretty cluttered here, and we can kind of see we've got our 3 tubes right here. We've got our transformer over here. We've got our power coming in, transformer, bridge rectifier to turn it into DC. Come out, got some filtering here. And then we come into the series regulator tube, the V9. It's a 12B4A. And we come out of it, and then this is our 272 going out to everything. So as you can see, regulated 272. This is very cluttered for what I'm going to explain. So I've cleaned it up, did a new sheet. It's the exact same thing, but everything removed that we don't need to worry about at the moment. Still got our power coming in, our transformer, bridge rectifier, getting our AC voltage here, getting our DC voltage here. Here's our series regulator V9. This would be our high voltage positive and negative out. And what I want to talk about is how this circuit works at a, kind of a higher level. Imagine you've got, say, 400 volts coming in here to this V9. Depending on what the grid is set to, you're going to have a certain amount of current able to draw through for any given load. So let's imagine that we have a load over here. It's going to be a variable load. Let's say at the moment it's fixed at a certain resistance, and we apply power to this circuit, and we're ignoring all of this. Forget this. The current's going to come through this tube here and feed a certain amount of current, and that current is going to create a certain voltage across here. Typical Ohm's law. If we were to put these resistors here in a pot across here and bring this line over to this grid where we could vary the voltage on this grid, we could vary with this potentiometer right here, we could vary the voltage that shows up here for any fixed load. The problem is we're now regulating on current. And we're not really regulating, we're just setting a current. So for a fixed load here, you could adjust this to get a certain current, get a certain voltage. But as soon as this load varied at all, the voltage is going to go all over the place. You have no regulation. Think of this thing like a big variable resistor. And by changing the grid, we can change the current through it, thereby changing the voltage that shows up on a given load. How it works is as you lower this voltage, more and more current flows through. As you increase this current voltage, this voltage, less and less current will flow through. This circuit would not work for us. We need something to automatically control this grid to constantly adjust the current so that we end up with the same voltage here no matter what load we're on. That would be our regulated supply. We'd go at it a little different. Instead of us controlling the pot controlling this, we add 2 more tubes in. We add an amplifier, and when I say amplifier, I don't want you to think of it like an amplifier like an audio or RF amplifier. This is an error amplifier. It's going to amplify a difference. It's going to figure out a difference, and it's going to amplify that difference. This is a voltage reference tube. Its purpose is to provide a fixed voltage to this tube so that you have something to reference to. I've got a very steady voltage here, okay? It's not going to move. So that gives me a reference here to compare my output voltage to see if it's changing. If this was not fixed and was moving all over, my voltage would always be, I'd have no target to hit to hold steady. So this provides me a fixed voltage into the tube here, for the error amplifier. And then what error I'm looking for is through these resistors and this pot, I feed into one of the grids on here, this voltage, not exactly the voltage because I'm varying it here with a voltage divider, the pot. And what this does is this sets the difference between this and what I want. So as I adjust this, I get a voltage from here which will move with this voltage. My output voltage moves, this voltage is going to move. This allows me to set this voltage because once I move this till I get the voltage I want here and leave it alone, this is going to follow because this voltage is steady and not going to move. You're saying, okay, based off of this voltage and the difference to this voltage, output of voltage. And so what happens is you get current across here, which creates voltage because of some resistors. We don't have everything in here. I'm keeping it very plain. This is not a complete circuit, if you will. So what happens is the output of this tube now controls the grid of our series regulator. So this tube takes a fixed voltage from here, compares it to what's coming in here. If this changes, this changes. So it can change 2 ways. Think of it this way. This voltage in here can change 2 ways. I can turn this to change the voltage to what I want it. Or if I'm not turning this, if this voltage moves, it's no different than me turning this. Because if this voltage varies, this voltage coming out here varies. These are linked to themselves by a ratio of this voltage divider circuit. So once I set a voltage here, by varying the voltage on that grid, any voltage change here varies the voltage on that grid. This in turn amplifies the change, puts out more current, creates a different voltage here. It's opposite. Therefore, if this voltage goes up, this voltage goes up, this voltage goes up, this current reduces, making this voltage go down. Vice versa. Just around and around in a loop here. We have a feedback loop. This is feedback, and this is a feedback loop. So that's kind of the circuit altogether. There's a lot of capacitors and resistors that need to go in here. And so the problem is the resistors and capacitors they have set up in here are done in a way to limit our variation. We don't want that. So what I'm going to do is I'm going to change this, 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 a couple of other resistors that are in here and capacitors I'll be changing. So basically, let me pull the whole chart out again. Basically, what I'm going to do is I'm going to kill off the output to the rest of the system, make this my output on the front, start changing components to get what I need, and turn this circuit into, let's see, I'll probably changing that. This will probably get changed. Capacitor will be fine. Capacitor will be fine. This resistor will need to change. This resistor likely will need to be changed. And by changing these components, I expect to be able to get a variable output from here of, I'm hoping 0, probably not, probably something like maybe 60 volts to maybe 300 volts. So that's what we're hoping for. Then the next part is you have additional windings on the transformer here and here for 6.3. Now we need to keep the 6.3 for some of these. So what I'm going to do is I'm going to bring 6.3 out of one of these out to the front panel also. So I'm going to give myself 6.3 volts on the front panel off of one of these windings. Just got to figure out what I can do about swapping tubes around to move. I know I need V9, so I'm going to have to move him into the chain here, figure out what I don't need here, pull one of these tubes out, and then that will free up maybe this winding. Anyway, somewhere I have to get this feed here from the winding. Figure out a way if I can free up one of these windings to give me 6.3 volts for heater filaments out of my power supply. That's my plan. So that's what we're going to do. I'm going to go start doing some work on it. I'll come back when I've got a little work done, and we'll see how I'm making out on it. So hope to see you in a little bit. Okay, I'm back. It's the next day. I put a couple hours into messing around with this thing, tracing things down and figuring out where stuff was. And I did a few mods to it, and I did get my voltage swing to vary substantially more. So let me show you where I'm at, and then let me show you the problem I've run into. This meter here, the 34401 at the bottom here, is currently connected over here to the output of the voltage regulated power. So that's regulated power. This potentiometer right here is what adjusts that. Obviously, we would move that to the front panel if we get this to work the way we want it to work. This meter up here is going to be ammeter, and I'll explain a little more about what we're going to do with that in a few minutes. But first, let me show you where I've got it. If you remember, we were swinging around 20 volts, centering somewhere around 272, which is the voltage you're supposed to adjust for. So we had very little swing, but we were right in that area. So 272 to say 282 down to 262, somewhere in that range. So let me show you what I've got now with my mods. Okay, it's going to stabilize somewhere around 350. So we're maxed out at around 350, and I can bring it down to about 128. So 350 to 128, pretty happy with that. I was hoping to get down around 100 to 300, but I'm getting more voltage than which makes me happy. That's good. But you can see I can get down, roughly 130, let's say, up to 358 when everything gets warmed up. So it's going to be about 130 to 360, basically. So obviously a lot more than 20 volt swing. So I'm happy about that. But here's where the problem comes in. When I load the circuit where I expect it to be regulated. So let me set up the voltage to say around 200 volts. Let's get her somewhere in the ballpark. It doesn't matter, but say roughly 200. Okay, roughly 200 volts. What I've got here is these power resistors here. We're not going to be using them in our power supply. So they were cut out of the circuits, and I got to realize they're handy to be right there. They're perfect for a load for this circuit for testing. So what I've got is I've got two wires sitting up here. I've got two of them. This is a 10K, 10 watt. This is a 4.7K, 20 watt. So if I go to, let's say, the 10K, and I've got the ohm meter, I mean, an ammeter set up here, the little O one. If I connect up, I'm going to load this circuit down and keep an eye on the voltage as I do this, but I'm going to load this circuit down. So here we go. Okay. You can see I'm pulling about 18.7 milliamps. And look at the voltage. Instead of 199, I'm 189. I've dropped about 10 volts. So we're not regulating that great. Okay. So if I undo that, I'll be right back about where we were. Let me put a little more load by going to the 4.7 resistor. You'll see that we get more current. We're pulling about 42 milliamps, and we're drawing it down. Oh, let's get on there good. It doesn't even look like I'm drawing as much, which is interesting. So let's go back to this one. 189, what are we getting here? Oh, I'm the same, 189. So I'm dropping the same no matter what I'm doing on load. Notice that on this resistor, I'm pulling 42 milliamps. On this one, I'm pulling, good, 18. So I'm over doubling, and the voltage drop sag is no different. It's about the same. So my thought is, well, why is the regulating circuit not working? Well, maybe the high voltage on this unit in its normal, milliamp meter design, maybe it wasn't designed to provide that much current. Maybe it only needs a couple milliamps, and this is just too much load for it, which is going to make this useless to me as a power supply if it doesn't have enough current. So I got to think about that. I said, well, how could I test that? How do I test whether it's sagging from the transformer sagging, the power supply end sagging, or whether the regulator circuit's not doing its job? I got to thinking, I said, well, okay, here's what I can do. What if I take and bring out, instead of the power from the regulated circuit, the power straight from the power supply section, okay, here. So this is the power from the transformer through the full wave rectifier into the capacitors, and I'm getting 470 volts, which that's about what I expected. And my question is, how much is that sagging while I'm doing this? Let's take a look. Let's put a big load on it. So let's put this load on it, the 42 milliamps, and it's sagging from 470 to 440. So it's definitely dropping, but you would expect that. But here's the thing, it's not dropping below the 200 volts that we set up. That means the regulator circuit has lots of overhead to turn it up to keep my voltage where I need it under load. It's obvious your voltage is going to sag. You have to turn it up to keep. That's what a regulator does. It turns it up to keep it there. We know that putting a load on a, when you look at an open voltage on a power supply, it's going to be much higher than loaded. So that makes no sense. It's definitely not the power supply that's doing it. So if we look at it from that point of view, okay, we've got something going on in the regulator circuit. I do not know why it's sagging. So then I had the idea of maybe my mods have caused the problem, right? So I went back and I undid all the mods, got it back to where it had the same 20 volt variation and the same volt range, acted just like it did before I touched it. I did this test and it acted exactly the same. I could only vary the voltage a small amount, but it acted the exact same way. The voltage dropped, basically 10 volts with any load. Removing the load, it did not appear to be trying to hold the voltage. So I'm not sure what's causing it. So I'm going to do some more work. I'm going to do a little more research into it, try to figure out why it's not regulating. That's where we're at. I'm going to do as much research as I can. I'll come back and give you an update and let you know where we're at as I move along on this. So, hey, thanks hanging in here for me.